So, complementary relationships. Can anyone remember what a complementary angle is?
Yes. Complements to 180 degrees. I guess.
Close, that's supplementary. Complementary is 90 degrees. So that's what we're going to be looking at, like angles that make up 90 degrees, kind of, essentially. It's not too bad. Okay, so I'm going to start off by drawing the first quadrant of our unit circle.
I'll just change this on being short.
Okay. Right, so I've made this angle here called theta. And I'm going to make a triangle out of it. A right-angled triangle. And let's just call this point theta. I'm going to call this side of the triangle A and this side of the triangle B. How do we find what A is?
Pythagoras.
Not quite.
Radius.
It's an x. It'll be the same as the x value at this point.
1.
It's cosine or sine? It's cosine, right? It's the x, so it's cosine. How to find B?
Sine.
Sine theta, yeah. Okay, so what if I take the same angle and I make it come off the horizontal axis? So roughly here. So this here is also theta. I'm going to draw a triangle. Right angled. And I'm going to call this P what? Any ideas? Think about going from 0. What's this? What's the pi on 2 minus theta.
So that first one, is that just P pi?
Yes, this is P of pi. No, theta. P of theta. Yeah. And this is P of pi on 2 minus theta, because we're at this point. Okay, what is this side the same as?
A.
A. Yeah. So this one is A. What's this side the same as?
B.
B. Right. How do we find this A value?
Sine. Cosine.
Sine, right? Because this is the Y. It'll be the same as the Y point here. How do we find this one?
Cosine.
Cosine. Right. So what we actually find is that cosine angle, let's say cosine theta equals sine of pi on 2 minus theta. Right, because this cosine theta is this side here, and sine of pi on 2 minus theta is this side here, and they're equal. Similarly, we can say sine of theta equals what? Minus theta. Yeah. That's basically it. Okay, now what if we've got y, x, the first 2 quadrants of a unit circle. And we say again that this one is theta. Let's make a triangle. We'll call this one A. We'll call this one B. Now, what if we have the same angle theta, but coming off the other way from the vertical? So roughly here. This one would be theta. What would this side be the same as?
A.
Yeah, B. And what would this side be the same as?
A.
A. Imagine all you've done is just taken that first triangle and rotated it around.
Okay.
Essentially, it's just like taken it and kind of rotated it around the origin. Okay. What is this? How do we find this A? Cosine theta. Oh, first things first. This is P of theta. What's this point here?
Pi on 2 plus theta.
Yep. Pi on 2 plus theta. Right, so cosine theta, that gives us A in the first triangle, is the same as what?
Sine that gives
Sine of this other one, this other angle. Because they both equal A. How do we find this B? Sine theta. And what's it the same as? Yep, but it's now negative because you're going into the negative. So it'd be negative cosine pi on 2 plus theta. Now, if we've got that's a terrible circle, but you get the idea. Right, we'll keep our original one. That's theta in there. What if we have the angle coming off the bottom? So that's theta in there. This is P of theta. A and B. What's this P of?
2 pi.
Wait, hold on. What's this?
Pi. 3 pi on 2.
Yep, 3 pi on 2 plus theta. Very nice.
Cosine.
And what is this side the same as?
No. What side?
This side here.
That's A.
It's A. What's this side same as? B. Very nice. Okay, so cosine theta is the same as negative sine of 3 pi on 2 plus theta. Right, because it's negative y value. Okay, and similarly, we've got sine theta is the same as what? Yeah. Cosine 3 pi on 2 plus theta. Quite good. And last one. Got our original theta. A and B. This is P of theta. What if we've got it coming off the other way? P of what?
3 over 2. 3 pi over 2 minus.
Yep. Right, this side is the same as A, and this would be the same as B. And this would be theta in here. Okay, so cosine A, or cosine theta, sorry. Cosine theta is the same as negative sine of 3 pi on 2 minus theta. And sine theta is the same as negative cosine 3 pi on 2 minus theta. Yep. Okay. That's essentially all you need to know. You want to try some examples? Right, so our first example, if cosine alpha equals 0.8, find sine of pi on 2 minus alpha. Right, let's draw it out and see why it happens. Right, this is angle alpha. It's cosine, so it's this one down here is 0.8. Right, we've got pi on 2 minus theta, so that's coming out this way. Alpha. We know that this side is going to be the same as this side down here. Yeah, so if we're finding sine of this angle, that's the y side, and it's the same as that x side. So therefore, oh yeah, we had the rule before. We'll go back to the rule. We said that cosine angle equals sine pi on 2 minus angle. Therefore, they're equal. So you've got sine pi on 2 minus alpha, 0.8.
Yeah, you got it.
Right, we'll try another one now knowing what you know. See if you can work it out. For 0 less than x less than pi on 2, and cosine x equals sine pi on 3, find x. Alright, so you got cosine x equals sine of pi on 2 minus x. See how they kind of line up? Right, this x matches this x. This pi on 3 matches this pi on 2 minus x. So pi on 2 minus x equals pi on 3. What does x equal? Right, just rearrange it. Yep, so pi on 2 minus pi on 3 equals x. So we've got x equals, just for the sake of it, let's make the common denominators. So 3 pi on 6 minus 2 pi on 6. X equals what? Pi on 6. There you go.
Can you just go through where?
It ends up saying cosine pi on 6 equals sine pi on 3. Right, they're the same. Okay. So like if you got it like that, you could say, oh, pi on 3, like let's make it in terms of pi on 6, and it would be pi on 2 minus pi on 3. No, sorry, pi on 2 minus pi on 6. And then you can see that they are equal. Kind of make sense?
Yep.
Yeah. If sine t equals 0.3, find cosine pi on 2 plus t. Right, so it looks like this. That's t. That's 0.3 because it's sine, it's y value. We're looking at pi on 2 plus t, so it comes out this way. T. That would be the same as up here, but it's coming out the negative direction, so it'd be negative 0.3. And the rule that we had before was sine theta equals negative cosine pi on 2 plus, sorry, theta. So therefore we know that cosine pi on 2 plus theta is the same as negative sine theta, because you can switch that negative back and forth. It can go either way. So we know that cosine pi on 2 plus t is just equal to negative 0.3. I personally think it's a lot easier just to draw yourself a little diagram, because then it's really easy to see where the negatives and where the positives are. Because sometimes when you write it out formula way, it's like, what is going on? But if you draw it in a diagram, you can clearly see that that is a negative value, a negative x value. Yeah. Last thing. The Pythagorean identity.
Yeah. Wait. Is this a different chapter or is this the same?
This is the same chapter, 16K. Pythagorean. Theta here. Right angle triangle. That's 1 because it's the unit circle, so the radius is always 1. And, right, how do we usually find this side along the x-axis?
Cosine.
Cosine theta. Good. How do we usually find the line? Yep, sine theta. Right, by Pythagoras' theorem. A squared plus b squared equals c squared. So we've got sine theta squared plus cosine theta squared equals 1 squared. Yeah. Amazing. Maths. Right, now let's just simplify this. There is no real easy way to say this, but for some reason, instead of writing sine theta squared, we write it as sine squared theta. Don't question it. That's just the way it is. It's kind of like saying x times 3. We just write it as 3x.
Are we going to lose marks?
Just because.
Will we lose marks?
Well, it really depends on how generous I'm feeling, but just get it in your head now to write it like that. You should not write it any other way. Just remember. And 1 squared is 1. So sine squared theta plus cosine squared theta equals 1. That is the Pythagorean identity. Put that in your brain and keep it there.
So, Miss,
Yes.
like for a question, can we use this way or the other way? Like, is it a choice or like is it going to be 2 different types of questions?
2 different types of questions. Let's try a Pythagorean identity question. If sine x equals 3/5 and x is between pi on 2 and pi, find cosine x and tan x using the Pythagorean identity. Okay, so we know that sine of an angle is 3 on 5, so we've got 3 on 5 squared plus cosine squared theta equals 1. Rearrange it. So we're going to take that fraction over. Cosine squared theta is 1 minus 9 on 25. Keep going. Okay, so what's 1 minus 9 on 25? Okay. Right. Now we just square root. So cosine theta. I should be really saying x, to be honest. It should be x, because that's in the question. So it should all be x. But you know, doesn't matter. Right, you just square root it. So 16 on 25. Don't forget plus or minus when you take square root.
Plus minus is in the second one.
Yeah, I was going to get to that in a second. But good on you for seeing it. Right, square root top and bottom, so you get plus or minus 4 on 5. That's cosine x. Yes, so because you're in the second quadrant and cosine is x values, there are only negative x values in the second quadrant. So cosine x equals negative 4 on 5. Right, so tan x is sine x over cosine x. Sine x is what? 3 on 5 divided by, what's cosine x? Negative 4 on 5. Flip it and times it. Negative 15 on 20, which is negative 3/4.